Okay. So we will do some more examples, but keep this in mind that limit of a function at a point at x equals to some point is the height of the function close to that point. The close means when you get to the point from the left side, look at the height, and then when you get close to that point from the right side and look at the height. If the height from the left side and the right side are equal to a number L, that is called the limit of the function. Sometimes you get from when you go to the point A from the left, then you get one height, and when you go to the point A from the right side, you will get a different height. Okay, in that case we say the limit does not exist. Okay, for a function to have a limit at a point x equals to a, you need to have the equal heights close to that point A when you approach to A from the left and when you approach to A from the right. If the heights are equal, then that is the limit. The equal height is the limit. If the height are not equal, then the limit does not exist. Okay, so let us do this example. Find the limit x tends to -1 f of x, where fx is x squared plus 1. If x not equals to -1, there is -1 there, right? -1. Okay, there is +1, +2, +3, and so on. And this is 0, right? And then -2, -3, and so on. -2, -3. Okay, so you want to find out the limit of the function at -1. The function is given as x squared plus 1. If x not equals to -1, at all other points the function is given by x squared plus 1, but at x equals to 1 it is 1. So let us do, suppose this is 1, this is 2, this is 3, 1, 2, 3. I want to draw the graph of this one first, x squared plus 1. Okay, so at 0 it is y is x squared plus 1, right? So it is 1, because when you plug in x equals to 0 you will get 1. At -1, what is the height, or what is the value of the function fx, or what is y value? So -1 squared plus 1, right? That is 2. You see that? Because -1 squared plus 1 is +1 plus 1, that is 2, right? Similarly, at +1 it is 2. At -2 it is -2 squared is +4 plus 1 is 5. You see that? And at +2 it is 5 as well. So you see that basically this is a parabola, right? Y equals to x squared plus 1 is a parabola that is shifted up by 1 unit. So it will look like this. This is the graph of that parabola. You see that? So it is fx equals to x squared plus 1. But at 1, this parabola is true only for x equals to -1. So you need to have a small hole at -1. You see that? That is the small hole there, because at -1 the height must be 1, but there is a small hole there at -1. There is a small hole at -1. But what is the height at -1 though? What is the height at -1? It is 1. It says that should be. This is what the graph looks like. You see that? Actually, this one, I use this one just to draw the graph. But when you look at this one, this piecewise function, actually this point does not belong to this graph. Okay, that's why I have a open circle there. And then the closed circle is actually the functional value. At -1, the value is 1. But all other points except -1, it is that parabola y equals to x squared plus 1. That's why I made a small hole there. And then instead of that this is the point at -1. The y value is +1. This is what the graph looks like. Now let us find out the limit at -1. So when you get close to -1 from the left side, let us get close to -1 from the left side. What do you get? Okay. So when you get close to 1 from the left side, the height will look like this. The height is like 5, right? At -2 it is 5. And then getting close to -1, getting close to -1, close to -1, close, very close to -1. At very close to -1, the height is almost +2. You see that? And if you go to -1 from the right side, meaning if you go let add 1, it is 0, the height is 0, and then add 1.2, negative 1.2, negative 1.4, negative 1.8, and negative 1.9. You see that the height is again almost 2. So from either side, the height of the function is almost 2, right? So what you write is limit x tends to negative 1 fx is almost 2, right? Or the limit is basically 2. This is how you find out the height of the function. You see that? Or to find out the limit, this is how we use the height of the function to find out the limit at a point. Basically, you don't worry about the height of the function at negative 1 because this is the functional value. We don't worry about the functional value to find out the limit, okay? So what we see is we check the height of the function close to 1 from the left and from the right. From the left, the height was almost 2. From the right, also the height was almost 2. So we say that the limit exists because the height is equal from the left and right side, okay? So basically we will cover the left limit and the right limit in the next chapter, but let me give you slight idea of what is the left height and the right height. So what do we say here is limit x tends to negative 1 from left. This is what we write. 1 to the negative 1 means we are getting to negative 1 from the left. You got that is 2, right? Similarly, limit x tends to negative 1 from the right. If you have to say from the left, we write negative 1 in the exponent of that limit, okay? And similarly, if you want to see from the right, we denote by 1 plus fx equals to also 2. Since these two values are equal, left limit and the right limit, we call left limit. And this is right limit, okay? Right limit. So since the left limit and the right limit are equal, they are equal to 2, so the limit is basically 2. So the limit of the function, both are equal to 2. That's why the limit of the function at negative 1 is 2. Okay? So again, so the limit of a function at a point A is the height of the function close to A towards the left and height of the function close to A towards the right. If those heights are equal to a number, that number is called the limit, okay? If those heights are not equal, then we say the limit does not exist. Okay, let us see this another example that has the limit does not exist, okay? So we will find out, we'll first draw the graph. So I want to draw the graph at of this function. There is an absolute value. Do you know the meaning of absolute value? If there is a negative number there, it will be positive, okay? That's what the meaning of the absolute value. So what I want to do is I want to draw the chart first, make the chart, and then draw the graph of that, okay? So what I want to do is let us plot when x is 0, what happens? Let's say when x is 0, then what will be the y value? Y will be that, right? That is the y value. The whole thing is the y value. Let's plug in 0. So 0 minus 6, what do you get? You will get 0 minus 6 absolute value over 0 minus 6, right? That is 0 minus 6 is negative 6, but absolute value cancel that negative sign. So it will be 6 over negative 6. So you get negative 1. So that is negative 1. Okay? Let me plug in 2. Okay, for x. If I plug in 2 for x, what do I get? I get 2 minus 6 over 2 minus 6 here, right? So what is 2 minus 6? It is negative 4. But the absolute value of negative 4 is that will be positive 4, right? That will be positive 4 divided by negative 4 because 2 minus 6 is negative 4. So positive 4 over negative 4 is negative 1 again. You see that? So that is also negative 1. If you take 4, that will be negative 1 as well. If you take 6, we don't know how much is that. Okay, because you see 6 minus 6 is 0 over 6 minus 6 is 0. So we don't worry about that because we don't have to check at 6 because we are trying to find out limit at 6. Okay, so let us find out at 7. What do you get? If you plot 7 here, you'll get 7 minus 6 over 7 minus 6. That is 7 minus 6 is 1, absolute value of 1. If there was a negative sign, then you get rid of the negative sign, but there is positive, so 1 over 1, that is 1. If you take 8, So you get 1 here. If you take 8 for x, what do you get? You will get 8 minus 6 absolute value over 8 minus 6 without absolute value, right? So 2, absolute value of 2 over 2, that is basically 2 over 2, because the absolute value is to get rid of the negative sign. If there is any negative sign, absolute value, write just that number without negative sign. If there is no negative sign, no worries, you can remove the absolute value. Okay, so that is also 1. So that is 1. So similarly, if you take 9, you will get 1, and so on. Okay, now let us draw the graph. So to draw the graph, we will plug in at 0 it is negative 1, at 2 it is negative 1, at 4 it is negative 1, and we don't know at 6, but at all other points the graph will look like this. And then at 6, this is the open circle there. Okay, we don't know what is at 6 because it is 0 over 0, so it is undefined at 6. Okay, now at 7, 8, 9, you see the positive 1, positive 1, positive 1, right? And then when you draw the graph at 6 again, at 6 there is an open circle. See, at 6 the function is not defined, but to find out the limit we don't care whether at 6 the function is defined or not, because we are trying to find out the limit. At that point it may be defined or not defined, but we'll look at the height of the function close to 6. Okay, let us look at the height of the function close to 6. Okay, when you get to the 6 from the left, the height is down, right? Negative 1, negative 1, negative 1, negative 1. Close to 6, towards the left, it is negative 1. You see that? From the left, it is negative 1, right? All the time. Close to 6, from the left, it is negative 1. Height is negative 1. But close to 6 from the right, the height is positive 1. You see that? So from the left side, the height is positive 1. Sorry, negative 1. And from the right side, the height is positive 1. So how do I write that? You see that? Limit x tends to 6 minus, that is from the left, fx is negative 1. And then limit x tends to 6 plus fx. So the plus and minus is to denote only the left side and the right side limit. Okay, is positive 1. Positive 1. You don't have to write positive sign, but I just wrote, that's fine. So from the left it is negative 1, from the right it is positive 1. Are they equal? No. So the limit does not exist. How do I write that? Limit x tends to 6 fx is does not exist. DNE. That is does not exist. This is how we write the does not exist case. Okay, guys? Let us see the last example now. Okay, so we answer the following questions from the graph. Okay, so what is f at negative 2? So this is not limit, right? This is called the functional value. What is the height of the function at negative 2? At negative 2, oh, there is a vertical asymptote as negative 2. So the height of the function is does not exist, right? So there is no height, does not exist. Okay, how about limit at negative 2? Limit of fx at x tends to negative 2. When you go to the negative 2 from left, the height is negative. When you go to negative 2 from the right, height is positive. So they are not equal, right? The height towards the left and towards the right are not equal. So the limit does not exist too. You see that? What is the height of the function at 0? At 0, this is 0, right? At 0, the height, this has an open circle. So this is not included, right? So this curve is not included there. So the height is here, it's closed circle here. So the height of the function at 0 is 4. So that is 4. That is the functional value, right? How about the limit at x tends to 0 fx? When you go to 0 from the left, the height is this function. You see that? When you go to 0 from the right, the height is that function. You see that? Because the height is basically that function takes the height. So from the left, the height is less than 1, almost like positive 0.5. When you go to 0 from the left, the height looks like 0.5. When you go to 0 from the right side, the height looks like positive 4, right? So the left limit and the right limit, or the height towards the left and towards the right, are not equal, meaning the limit does not exist. Okay, how about f3? The height of the function at 3, it is 0.5, right? It is like almost equals to 0.5. So I would write 0.5. How about the limit? So, oh, by the way, so at 3, f3, what is the height at 3? The height at 3, there is an open circle there, right? So that does not exist there. So there is open circle, so it does not exist. So the functional value does not exist. You see that? At 3, the height is, there is no height. The functional value does not exist because it is the open circle. Now how about the limit? You see that dotted line? When you go to 3 from the left, the height of the function is almost 0.5, right? If you go to 3 from the right, the height of the function is almost 5 as well. You see that? That is the height of the function, getting close to 0.5 and getting close to 0.5 as well. So the limit is basically 0.5. How about f at 4? So at 4, the height is that closed circle, right? Not that open one, because the open one looks like 4, but height is 2, right? So the height of the function is 2 at 4. The functional value is 2. But how about the limit? Limit is, you don't look at 4, you look at the close to 4. You see that? So let us look at the height close to 4. So when you go close to 4, it's almost 4, right? Close to the 4, the height is almost 4. You see that? From the left side, it is almost 4. From the right side, it is almost 4. Meaning the height, the limit is basically 4. At the point 4, the limit of the function fx, the height is also 4. So this is how we calculate the limit of a function from the graph.